Welcome to the second video in our Twitter module creation series. At the end of the last video, we had created our Twitter login module that inherited from the base login module. In this video, we will be going over the files created to implement the Twitter contact module with a menu and user input. This module utilizes the Balek syncedCommander class to easily sync state between the instance and the interface while providing instance commands to the interface. Hopefully, after watching this video, you will have a better understanding of how the syncedCommander is implemented, as well as an idea of how your files can be organized when creating a module. At the end of this video, we will commit these changes to the repository so you can follow along using Git. These are the 10 files we are going to stage and commit to our repository at the end of the video. In my IDE, you can see they are marked red because they have not been committed yet. Notice the 3 JavaScript files in the contacts folder: module.js, instance.js, and interface.js. They may look familiar from the last video as they form the base of a Balek module. Let's take a look at the module.js file to see how it is different from our login module. The main difference is the allowed sessions array is set to 1, which means this module instance can only be loaded to a connected session controlled by a user. However, if the user disconnects, the module instance will stay loaded in the session. We also see that the display name and declared namespace are unique to this module. Now let's look at the main instance object that is loaded into the session for the contact module. We see that this instance requires the contacts menu instance file, which it uses to create the contacts menu instance. It also requires the syncedCommander instance file that it uses to extend itself in order to push the interface state to the interface and to allow the interface to send commands to the instance. In order for the remote commands to work, once the instance is extended by the syncedCommander instance, we need to set the commands object and call the setInterfaceCommands function in the instance. We do this in our instance constructor. The commands object is a list of key value pairs. The key is the name of the function that is available to the interface, and the value is the function that is called when the instance receives the command. I usually hitch this function to the instance object to make the instance this object available to the function. After setting up the remote commands in the constructor, the instance requests the user key from the session manager to pass to the contacts menu object when it is created. The contacts menu will use this unique user key when performing database queries once they are implemented. The new contacts menu's keys are then passed to the interface through the interface state object. Once the interface is connected to the instance, it will receive these keys, which it will use to create the contacts menu interface. Let's take a look at the contacts module interface file. Because we extended the module interface with the syncedCommander interface, the onInterface state change method is called whenever there is a state change from the instance. Because the interface was created by the module manager using the instance key, the syncedCommander interface extension has already connected our interface state, and all we have to do is create the onInterface state change method. When the contacts menu instance keys are received in the interface, we check that the keys we are expecting are included in the new state, then create our contacts menu interface. When we create the contacts menu interface, we pass the contacts instance commands so the contacts menu interface can call the import contacts function. We also pass the component key, which is needed by the component to sync its state with the contacts menu instance. Now that we see how our contacts menu instance and interface are loaded through the contacts module, let's take a look at those files next, starting with the instance. The contacts menu instance has no commands for its interface, but we want to be able to push the state to the interface. So it extends itself with the state synced object instead of the syncedCommander. Because of this, we have to call the prepareSyncedState method in our constructor from the stateSynced class in order to generate a component key that we can use to create our interface. We also set the interface state status to ready. But that's pretty much it for the contacts menu instance at this point. Let's move on to our first Dojo digit widget, the contacts menu interface. The login module interface was actually a Dojo digit widget as well, but we didn't have to create the HTML and CSS templates because they were included in the base login interface. When we create a Dojo digit widget, we need to include a template string variable as part of our interface. We can store the whole template in a file and include it in our interface with the Dojo text module. We see that our contacts menu interface requires both an HTML and CSS file that are stored in the resources folder. The HTML template is then assigned to the template string variable, and the main CSS file is used to create a style tag in the document body. We see that this is done in the constructor of our interface. Because the interface is also using state synced, we call the AskToConnect interface method in the constructor as well. We put this call inside a Dojo ready call so that it is executed after the widget is ready. Once the widget node has been created, the postCreate function is called. This is when we add the DOM node to the main content layer through our UI manager. If we have already connected our state and received a status of ready, then we fade in the node. In our onInterface state change method, we fade in the DOM node if it exists when we receive the ready status. In the events section of our interface, we have our onAddContactClicked function that gets called when the Add Contact button is clicked. This function is attached in our HTML template using the Data Dojo attach event prop on our button div. We see that the template also uses the base class variable to set the class of our divs. Looking at our JavaScript and CSS file, we see how this works. Back to our onAddContactClicked method. When the Add Contact button is clicked, we make a new getUserInput widget to get input from the user, and then we use that input when calling our import contacts instance command. This returns a promise that resolves when the instance uses the callback method. Bringing up the import contacts command in our instance, we see that it simply checks if the names are a string or array and replies that it cannot complete the requests. And in the interface, when the promise is resolved, it logs the reply to the console. The getInput status is a pretty straightforward Dojo digit widget and something that if you are interested in, reading the Dojo documentation and inline comments should answer most of your questions. As Balek evolves, I plan to add more UI widgets like this to the base system. The getInput status we use in this module accepts an input string or JSON file. We see that both inputs are acting as expected, sending input to the instance and receiving a reply. Our next step is to access the Twitter API to resolve these names. This will be the focus of the next video in the series. Let's go ahead and wrap this up by committing our changes to the Twitter branch of the Balek repo on GitHub, so you can check it out on your own machine. If you have any questions or comments, please leave them on YouTube and I'll attempt to answer them in the next video or in a reply. And thanks for watching.